Okay. Basically, we're doing SOHCAHTOA today. Do you remember SOHCAHTOA? So, ka, toa. What does the O and the H stand for that's paired with a sign? Opposite over hypotenuse. Adjacent over hypotenuse, good. I don't know why I'm not writing this where I was supposed to, but, and toa, opposite over adjacent, good. So it's the sine of some angle, cosine of some angle, tangent of some angle equals the ratio of the opposite over the hypotenuse side or adjacent over hypotenuse. Is that hard to read for some reason? It wasn't? Oh, it was hard for me to read. So there we are. Okay, so the first three here where the pictures are already drawn for you is a complete review. So your angle that you have is 37 degrees. So based on the side that you know and the side that you're trying to figure out, what are those? Are those of the three, opposite, adjacent, and hypotenuse? Which two of the three do we have? We have the opposite that we're looking for and the hypotenuse. So which one involves opposite and hypotenuse? Sine, exactly. So it's the sine of 37 equals the opposite, which is x, over the hypotenuse, which is 20 feet. So just to solve for x, to undo dividing by 20, you multiply both sides by 20. So times 20, x equals, and just type that in. X, 20 times the sine of 37. And to the nearest tenth of a foot, so 12.0, right? 12.0. Okay. This one, she didn't actually label the right angles, but I think we can tell that that one's the right angle. So the angle that we know about is this one. And of the three sides, opposite, adjacent, and hypotenuse, what do we have? We don't have opposite. We have the adjacent, and we're looking for the hypotenuse. So adjacent and hypotenuse means we're using cosine. So Bean, can you set that up for me? Well, cosine is which over which? Adjacent over hypotenuse or hypotenuse over adjacent? So which is the adjacent side? The x or the 19? The 19. Technically, the word adjacent does mean whatever one's next to it, and they both are technically next to it. But the hypotenuse trumps anything. So that's definitely the hypotenuse, which means the adjacent is 19. Over x, correct. Now, when you guys solve this, what are you used to doing? You put it over 1 and cross multiply, okay? So then we'll stick with that. So x times the cosine of 35 equals 19, and then we would just divide both sides by the cosine of 35. So 19 divided by the cosine of 35 gives us 23.2. So sometimes the missing side you're looking for is on the numerator, sometimes the missing side you're looking for is on the denominator, and sometimes you're not looking for a side, you're looking for an angle. So based on the fact that this is the angle we're looking for, which sides do we have? Opposite and adjacent. So which function uses those two? Tangent? I heard someone say that. So it's the tangent of x. You always take the sine, cosine, or tangent of the angle. Equals what over what, Faith? Good. Opposite is 15 over adjacent is 12. And how do we solve that on a calculator? Inverse tan. Inverse tan of both sides. We'll leave x all by itself, and then the inverse tangent of 1512. 51.3, and that's in degrees, because we were looking for the angle. The other two were in feet. So, quick review of those. You guys sound like you pretty much remember that well. The only thing we're doing today is kind of using that property, but it's going to be kind of wrapped up in word problems with angles of elevation and angles of depression. So we'll have to draw our own picture, which is half the battle, and then you'll set it up like once you have your picture drawn, you'll be able to do any of those methods. So, at a point on the ground 40 meters from the foot of a tree. There's your tree. There's the foot of the tree. From a point on the ground that's 40 meters away, that'll make that 40. What's that? No, we haven't done angle of elevation depression yet. Oh, yeah. You did it in geometry. Yeah. I thought you meant reviewing here. Yep. That will be number 7. So the angle of elevation from there to the top of the tree. So the angle of elevation is like your line of horizontal sight to the line of wherever you're looking up or down to. In this case, we're looking up. So the horizontal with that line of sight that you look along that line is 42. And they want you to find the height of the tree, which is which side? Right, X, the opposite. So based on the angle that we know, which two sides do we like? Opposite over adjacent, which means we're using the tangent of 42 equals X over 40. Good. And we won't solve that because we just did all that above. Okay? Yep. Angle of depression is usually a little bit trickier. Remember that angle of elevation is the horizontal line of sight along with the line of sight looking up. Angle of depression is going to be similar. It's the horizontal line of sight and then with the line of sight to the object you're looking at. So from the top of a lighthouse, and we'll let this be our lighthouse again, that's 200 meters high, an observer measures the angle of depression of a boat at sea to be 24. So let's pretend this is our boat over here. Okay? This is tricky because if you're doing an angle of depression, you're up top and you're looking down. So your horizontal line of sight is right here, looking that way. And your line of sight to the object is that way. Yes? The angle between them is what's 24. And that's tricky because that's not actually in your triangle, right? Agreed? That's not in your triangle. But when you see this Z, what do you think of? Parallel lines and what are those? Oh, Mrs. Grzanti, probably been using your wall over there. We're not talking. Alternate interior angle. So if this is 24, this is 24 as well, right? So here's the moral of the story. The angle of depression from the top looking down is the same as the angle of elevation from the bottom looking up. And so even if you're given the angle of depression from the top looking down to the boat, you might want to think of that as just the angle of elevation from the bottom going up. Because what I don't want you to do is label this 24, because that's definitely not 24 degrees. Does that make sense? Okay, so whether you're given the angle of elevation or the angle of depression, you can always just make that the angle of elevation from the bottom looking up, because you're more apt to be accurate that way. Mike? You could do 90 minus 24 and use that for sure. You can. It'll be the same thing. You'll end up using a different thing. So we're going to look for the distance from the boat to here. So if you decide to use this angle, you'll have X over 200 as your opposite over adjacent. We're going to use 24, so we're going to have 200, the flip of that. But they'll all be the same thing. So tangent of 24 equals opposite of 200 over adjacent of X, and you would solve that. Okie doke. And the last one, a vertical pole 20 meters high casts a shadow 16 meters long. Find to the nearest degree the measure of the angle of elevation of the sun. So here's your angle of elevation from the bottom looking up, right? Your sun's over here somewhere. Isn't that a pretty sun? So we're looking for this angle. Are we using sine, cosine, or tangent, Tommy? Tangent of what? Equals? Good. I have a question for you. Does anybody want a candy bar? No. Okay. This is a random trivia question. If your height of an object is 20 and the shadow at that moment is also 20, so they're exactly the same, what's the angle of elevation to the sun? Good job, Mike. 45. So if this becomes shorter and it pulls in like it does here to 16, like if that were to come in shorter, is the angle of elevation to the sun bigger than 45 now or smaller than 45? Because 20 and 20 is an isosceles triangle. You like that? Mm-hmm. You can give them a fist bump if you want. So maybe if I make it more extreme, you'll tell. If the shadow gets shorter, does your angle of elevation grow? Is that angle bigger than 45 or less than 45? Bigger, right. And if there's no shadow, where's the sun? Well, directly above. Right, right. Yes? Well, that was just for fun. No, that was just for fun. Oh, I did have another great question for you, though. You want a bonus for that quiz you just took?
Sure.
I don't know. Here's the bonus. If I give you separate sheet of paper. 10, 3, 5, and 12. What's the measure of that? Well, it's going to take you a while. No one's shouting it out. Oops, I don't want my hand there. That's creepy. I don't know whose test this is, but... Is it? Do you need more time on it? Yeah.